On this video, we will talk about the surface area of prisms and pyramids. So let's start by looking at some vocabulary words here. For the lateral area is going to consist of the sum of all the areas of its lateral faces. And the surface area of a solid is the sum of the areas of all its faces. What does this really mean? Well, let's take a look at a prism. So here we have a prism. Now, the lateral area, it's the sum of all the areas of its lateral faces. So notice that the lateral faces, this just refers to just all the possible sides, that surround. Here we have the back. So notice that here would have another lateral face, and here would have another lateral face. So if we were to add all the possible sides that surround this prism, that's what we refer to as the lateral area. It's just the sum of the area of the figures that surround the prism in a horizontal way. Now, the surface area is the lateral area plus the area of the base and the area of the base, which in this case, they should be the same value. So the lateral area just refers to the area that surround the figure. And the surface area, it's all the possible sides of the figure, which in this case is a prism, which is all the lateral area plus the top and the bottom. So that's what we refer to as the lateral area and the surface area. And at least when it comes to a prism, the surface area is the lateral area plus the two base area, which is what we just discussed previously, which is everything that surrounds plus the top and the bottom. And the way that we're going to define the lateral area of the right prism, that is the equivalent of the perimeter of a base times the height of the prism. But why is that? Well, let's take in consideration this prism. So let's just build a quick prism and let's see why is it that is true. So here we have, let me just build a quick prism. I want to try my best to draw a very accurate prism. So here we have the bottom base, the top base. Here we have these two sides should be connecting with each other. This should be the back. This should be the back. This should be the side. And now this is the front. And that is the front. So here we have a prism. Now, if we find the perimeter of the base of the prism, which in this case, let's draw the perimeter as P. If we find the perimeter of, notice that we're not finding the area of the prism. We're just finding the perimeter of the base of the prism. And if we multiply that by the height of this prism, then notice that if we get this line and we multiply it by the height, we're going to be covering this whole side. We're going to be finding the area of this possible lateral side. And in addition, if we get this little line and we multiply by the height, we're going to be getting the area of this side right here. But if we find the perimeter of the whole base, then we're really just finding the lateral area, because all we're doing is we're multiplying this line times the height. In that way, I'm always going to be covering. So here's the left, here's the right, and here's the back. So if I get the perimeter and if I multiply by the height, I'm always going to be getting just the area of the sides that surround this figure. Now, if I want to get the surface area, well, that is the lateral area plus the area of the top plus the area of the bottom. But since they're equivalent, we can just call it 2b. So that's at least how we're going to be finding the lateral area for a prism. We're going to be finding the perimeter of the base, and we're going to multiply it by the height. And to properly get the surface area, well, we're going to get the lateral area plus two bases, and the bases are equal, so I can just call it plus 2b. So that's the prism. But now for a pyramid, but the same idea, at least when it comes to the lateral area is just the area that surrounds this figure, which in this case is just whatever we exclude on the base. But for the surface area, notice that we only have one possible base. So therefore, the surface area is the lateral area. It is the lateral area plus just one base. And that's how we're going to be defining our surface area. It's just the lateral area plus one of those bases. Now, how can we find the lateral area? Well, the lateral area is the area of one lateral face times the number of the sides. So what do we mean by this? Well, let me just erase this. So if I find, let's do highlighter now. So if I find the area of one of the lateral sides, so at least what I'm drawing here, this triangle is what we call the lateral face. Now, if I find the area of this lateral face, I know one thing for sure. Since we're talking about a right a right pyramid, I know that all sides are going to be congruent to each other. So if I get this triangle and I know that all triangles are equal to each other, so in order for me to find the lateral area, it's just going to be the area of this triangle times how many of those triangles you have that surround this pyramid. So that's how we're going to be defining the lateral area. Well, how exactly do we find the lateral area? Well, since we're talking about triangles, so triangles are what are going to be surrounding my pyramid. Well, remember that the area of the triangle is 1/2 times the base times the height. Where for every triangle, the height of my triangle is what's going to be the L, or the lateral length. So perhaps we can just define it as the area of this triangle is 1/2 times the base times the lateral height. But notice that the base of my triangle is exactly one of the sides that surrounds my pyramid. So therefore, if we just expand this, now the lateral area, it's equivalent to the number of sides times the area of that triangle, which is 1/2 times b times L. But now notice that at least for the number of sides, I'm going to be just represented this as just S. So now I can say that this is equivalent to just 1/2 times S times B times L. But notice that the number of sides times the length of the base, well, this is equivalent to my perimeter. So therefore, I can just express the lateral area as just 1/2 times P times L. So this is how we're going to be defining the lateral area of a pyramid. We can just define the perimeter of the base, multiply by the lateral height, and times 1/2, since we're talking about triangles. But everything comes from the idea of the figures that are going to surround the pyramid are triangles. The area of a triangle is 1/2 times the base times the height. So the lateral area is the area of the triangle times how many we have them. So the number of sides times the area, but the number of sides times the base, that's equivalent to the perimeter. So I can just reduce this as the lateral area to be defined as 1/2 times the perimeter times the lateral area. So now that we have discussed all this, let's do some quick examples now. So let me just make some space and let's use all this information that we've been discussing. Now let's try to find the lateral area and the surface area of this figure, which notice that this figure is nothing more than a prism. So we're looking at a prism now. So how do we find the lateral area? Well, again, the lateral area is just the area of the figures that surround this prism, which let's just call them, let's call this side the left-hand side. Let's call this the front. Let me use a different color. So let's call this the left. Let's call this the front. Let's call this the right. And now notice that we also have another figure that is surrounding this prism, which is the back, which is this whole big square on the back. So let's call that the back. So therefore, the lateral area there are two ways to find the lateral area, and we're going to find them both ways. But the lateral area is just going to be the area of the left plus the area of the front plus the area of the right plus the area of the back. But how do we find the area of the left? Well, notice that the left, it's some kind of a rectangle. So that's going to be base times height. So at least for the area of the left, we can see it as being 5 times 10, because that is what we have here. So 5 times 10, that's the area of the left. So now how do we find the area of the front? The area of the front, that will be 6 times 10. The area of the right, well, that's going to be 5 times 10, because that's at least how we can find the area of this rectangle right here. Plus the area of the back. We know that the back, it's a solid rectangle, which it will be 12 times 10. So now if we simplify all this, so that becomes 50, that becomes 60, that becomes 50, and that becomes 120, which is equivalent to 280. Since this is the area, we can talk about centimeters squares. Or we can say that the lateral area, again, recall that we said that that was the perimeter times the height. Well, what is the perimeter? Well, let's take a look at the bottom. So the perimeter, the length is 12 here. So let me just erase what we do have here. So that is 12. That is 5. That is 6. That is 5. So therefore my perimeter is the addition of them all. So 5 plus 12 plus 5 plus 6, which is equivalent to 28. So therefore, the lateral area, it's equivalent to 28 times the height, where the height is 10. And notice that whichever way that we wanted to find that, we're still going to get the same conclusion. So you decide how you want to do it. You can just add up the sides, or you can just do perimeter times the height. So now we know that the lateral area, is 280 centimeters square. But we also want to find out something else. So let me just make some space. So now we just found out that the lateral area is 280. But now what we want to do, we want to find the surface area. We'll recall that the surface area, that's equivalent to the lateral area plus 2 times the base, or the area of the base. But what do we have as the base? Well, notice that now my base, it's a trapezoid. And I recall that the area of a trapezoid, that's 1/2 times the height of the trapezoid plus the addition of both bases. But now, since this is a prism, then the height of this is 4, so therefore this height is also equivalent to 4. Then this is 12, and this is 6, since it's literally just a reflection of what we have here. So let's just plug that in. So now we have 1/2 times the height, where the height seems to be 4, plus b1, which is 6, plus b2, which is 12. And now let's just simplify this. So 1/2 times 4, so that's 2. 6 and 12, that's 18. And 18 times 2, that would be equivalent to just 36 centimeters square. So now if we put it all together, then the surface area is equivalent to the lateral area, which we already found it to be 280, plus 2 times the area of the base, which is the area of the base, we just found it to be 36. So now this becomes just 280 plus 72, which is just equivalent to 352 centimeters square. Because notice that I'm using centimeters square now because we're talking about area. We're not talking about volume anymore. So therefore my units must be of a square. So this is a small example for the prism, but now let's take a look at a pyramid. So we're going to try to do the same, but now for a pyramid. So here we have a regular square pyramid, and we want to find the lateral area and the surface area. So let's take care of the lateral area first. Well, recall that we said that at least for a pyramid, the lateral area, it's equivalent to 1/2 times the perimeter times the lateral height. Times the perimeter times the lateral height. So now, let's see if we can find that information. Well, I can see that the perimeter is pretty easy to find because when we talk about perimeter, we talk about the perimeter of the base. So it's literally just the perimeter of the side, where the perimeter, in this case, that is 10, that is 10. So therefore this is 10, so therefore this is 10. So we can say that the perimeter is equivalent to 40. So the only thing that we're missing is the lateral height, which the lateral height, we can see it as being the distance from this point to this point right here. So this is the lateral height. Or it could have also been this, but notice that we're not going to use neither the front or the left or the back because we don't have information on that. We definitely have a lot of information on the right-hand side. So we definitely want to use that. So now our objective is to find the lateral height. So how do we find the lateral height? Well, notice that the lateral height, we know that this line must be perpendicular because that's just how we have defined distance between a point and a line. So now if we break this out, notice that we have some kind of a right triangle where we have 90 degrees here, where my lateral height is just this leg. And now we have a triangle where the hypotenuse is 13 and the second leg is 5. But now since this is a right triangle, we definitely have enough information now to find the value of L, because now we can use the Pythagorean Theorem. So phi squared plus L squared is equal to 13 squared. And now it's just a matter of finding the value of L. So this becomes 25 plus L squared equals 169. And all we're doing now is just solving for L. So let's take away 25. So now that way, we have that L square. We have that L square. That's equivalent to 144. So if we take the square root, L is going to be plus or minus the square root of 144, which is 12. But notice that here, even though it says plus or minus, since this is length, then we're just going to be using the positive value. So now we definitely have the value of L now. So we know that P is 40. And in addition, L is 12. So definitely we have enough information to find the lateral area, because now the lateral area can be defined as 1/2 times the perimeter, which we found it to be 40, times the lateral area, which is 12. And now if we simplify this, so 40 over half, that's 20, and 20 times 12, it's equivalent to 240. But now notice that, let's assume that the sides were given to us in centimeters. So therefore, the lateral area must have the units of centimeters square. So now we know how to find the lateral area, but at least we're halfway done. So we know what the lateral area is. So now what we want to do is now we want to find the surface area. But recall that the surface area, that's equivalent to the lateral area plus the area of the base. But we definitely know what the lateral area is. The lateral, oops, I think I didn't spell an E there. So the lateral area, we already found it to be 240. Here we go again. All right. We already found it to be 240. But now the area of the base, but notice that the base, it's a square. So definitely the area of my base is the area of the square. So that will be base times height. So 10 times 10, which is 100. So let's just highlight this for you to know where we're coming from. The area of the base we refer to as this rectangle right here. So now this is just a matter of just adding it up, because now the surface area, it's equivalent to just 340. And again, let's assume that everything's given in centimeters. So we got centimeters square. So the main objective here is to identify what is the lateral area and what is the surface area for at least two figures, and that will be prisms and pyramids. And with this, we conclude our lesson for surface area of prisms and pyramids.